Question number 5 from NEST 2010 on trigonometry. If sine alpha, sine 2 alpha, sine 3 alpha into sine 4 alpha is written as a polynomial in sine squared alpha, the sum of the coefficients of the polynomial is 0, 1, negative 1, 4. The problem is pretty straightforward. What we will do is, we will first write down the expressions for sine 2 alpha, sine 3 alpha and sine 4 alpha using double, triple and quadruple angle formula. Sine 2 alpha is 2 sine alpha cos alpha, we know that. Sine 3 alpha is 3 sine alpha minus 4 sine cube alpha, we also know that. For sine 4 alpha, you have to apply the double angle formula twice. First, we can write it as 2 sine 2 alpha cos 2 alpha. And then for this sine 2 alpha, we can again use this formula, so that is 2 sine alpha cos alpha. But now it will become 4 because of this 2. Okay. And for cos 2 alpha, we can write 1 minus 2 sine squared alpha. So a lot of trigonometry formula right at the first step. Okay. If you don't understand that, observe this. 1 is cos squared alpha plus sine squared alpha. And then when you subtract 2 sine squared alpha from that, it will give us cos squared alpha minus sine squared alpha. That is essentially cos 2 alpha. Okay? Acha. Now the next step is also pretty straightforward. Now what we will do is, we will go to the expression which we would like to express as a polynomial in sine squared alpha, and we'll put everything. Okay? So sine alpha as it is, sine 2 alpha is 2 sine alpha cos alpha. Then let me now select blue color. Sine 3 alpha is 3 sine alpha minus 4 sine cube alpha. And then finally sine 4 alpha is 4 sine alpha cos alpha into 1 minus 2 sine squared alpha. Okay. Now what I have done is, I have simplified the terms here. Okay. This sine and this sine squared, and then that 2 is there. Okay. The two blue underlines for this cos and the cos here, those two have given us cos squared alpha. Okay. Those two have given us cos squared alpha. And then what I have done is, I have also taken 1 sine alpha common from the red box bracket from sine 3 alpha, and there is another sine alpha here, and then that's 4. So that has become 4 sine squared alpha. After taking sine alpha common, this becomes 3 minus 4 sine squared alpha, and I have kept this 1 minus 2 sine squared alpha as it is. So we need to make sure that we don't miss out any term. Okay, sine alpha has been considered, 2 sine alpha cos alpha has been taken care of, 3 sine alpha minus 4 sine cubed alpha, yes, 4, yes, sine alpha cos alpha, yes, and this 1 minus 2 sine squared alpha, yes. Okay. Now what we will do is, we'll try to simplify this. Observe that this cos squared alpha can be written as 1 minus sine squared alpha, and we have to write it because now our expression only contains sine squared alpha. There is no sine alpha term, there is not sine cube alpha term, is only sine squared alpha. Okay. So let us now replace that sine squared alpha by x and simplify. Okay. Let sine squared alpha be x. So this 1 minus 2 sine squared alpha is cos squared alpha. That change must be done. So we will now get 2x into 1 minus x, right, because that is 1 minus sine squared alpha, into 4x into 3 minus 4x into 1 minus 2x. Care must be taken here, we are not substituting for sine alpha, we are substituting for sine squared alpha. Okay. It may happen that you end up substituting sine squared alpha as x squared, and you will get actually a polynomial of that degree which will be double of its original degree, because we want sine squared alpha as x and you substituted for sine alpha as x. Okay, so please don't do that, be careful. Okay, so this is our required expression now. Okay, this is our required expression. 2x into 4x will be 8x squared, okay, into 1 minus x. And how much will this be? Let us multiply the two box brackets. 3 into 3 is 3. Then negative 4x into 1 is negative 4x, and 3 into negative 2x is negative 6x. That will effectively be negative 10x. And negative 4x into negative 2x will be positive 8x squared. Okay. Now what we can do is we can multiply 8x squared by 1 minus x. So that will be 8x squared minus 8x cubed into this term as it is. And now let us open up the brackets. First let us multiply the second one by 8x squared. So that will be 24x squared minus 80x cubed plus 64x raised to 4. And then let us multiply the second bracket by negative 8x cube. So that will be positive 80x raised to 4. Oh wait, okay, let's first multiply it by 3. So that will be negative 24x cube, right? Negative 24x cube plus 80x raised to 4, and then finally minus 64x raised to 5. Okay. Now we have basically expressed it as a polynomial, right? And we want the coefficient, the sum of the coefficients. Okay. Now even if we don't do that, that's fine, because you see here that this is 24, this is negative 24, this is negative 80, this is positive 80, and this is positive 64 and this is negative 64. So sum of the coefficients is already 0. No need to add. Okay, sum of coefficients is 0. So what is the answer? The answer is A, option A. Okay. Now what we will do is we've got the answer, but now because we would like to see how the graph looks and whether that answer is indeed correct, I will rewrite it as 24x squared minus 114x cubed, okay, plus 144x raised to 4 minus 64x raised to 5, with x being sine squared alpha. Okay, now what I have done is I have plotted both these functions on Desmos. Let me show them to you. Okay, look, well here alpha is x, so okay, please note that, take it out. Okay, so sine x into sine 2x into sine 3x into sine 4x, that's the given expression, and this is how its graph looks. Okay, this is the graph of sine x, sine 2x, sine 3x into sine 4x. And now what I have done is I have gone for the graph of this one, okay, this fifth degree polynomial in sine squared alpha. All right. Okay, now you can see that, let me yeah, so this negative 64 x raised to 5 is this one, negative 64 sine x raised to 10. Then there is 144 x raised to 4, so sine x raised to 8, minus, oh wait, did I make a mistake? Yes, okay, I made a mistake there. 8 plus 2 is 10, my bad, so that is 104. Okay, I'm glad that didn't affect our answer, because we didn't add them, we directly cancelled that. Okay, so that is minus 104, right? That is minus 104 x cubed. Yes, that is minus 104 x cubed, so sine x raised to 6. Okay, and then finally we have got 24x squared, or 24 sine x raised to 4. Now if our coefficients are correct, okay, then our red graph should coincide with this graph. Let's see. It does coincide, because they are the identical representations of the same function, right? Okay, so our answer is correct. The sum of the coefficients is indeed 0. Now it would be interesting to see the range of this function. Okay, that could be another problem, and you might see that this range of this function is not between minus, well, not minus 1 to 1. Okay, in fact, if you see, its peak is even smaller than 1 upon 2. Okay, so you can take that as homework to find out what are the maximum and minimum values of the function and where are they attained. Okay, it's not minus 1 to 1. If it had been just sine alpha, then it would have definitely been minus 1 to 1. So you can take that as an additional question and simplify that. Okay, what's the thing? Find the range of, okay, sine alpha, sine 2 alpha, sine 3 alpha into sine 4 alpha. You can make use of this result if you want. Okay, you can make use of this result that you, if you want, because you know that here x will belong to closed interval 0 to 1, so you can use that as a tool to find the range of this one. Okay, I'm leaving that to you as homework. Comment your answer. Okay, and let's see what you get.